Welcome back to Java Internals Crashcasts. I'm your host Sheila, and today we're continuing our journey through the fundamentals of concurrency. We're in the synchronization fundamentals chapter, and we'll be discussing object locks and reentrant locks. Victor, are you ready to dive into this fascinating topic?
Absolutely, Sheila. I'm excited to explore these crucial concepts in Java concurrency with our listeners.
Great. Before we start, listeners, make sure you're familiar with the basics of threads and the synchronized keyword, which we covered in our previous episodes. Now, let's kick things off with a quiz question. What's the main difference between object locks and reentrant locks in terms of flexibility?
That's an intriguing question, Sheila. It touches on the core distinctions between these two locking mechanisms. Listeners, as you ponder this, consider how you might need to control access to shared resources in a multi-threaded application. Think about scenarios where you might need more fine-grained control over your locking strategy.
Excellent point, Victor. While our listeners think about that, let's start with the basics. Can you explain what object locks are and how they work in Java?
Certainly. Object locks, also known as intrinsic locks or monitor locks, are built into every Java object. When you use the synchronized keyword on a method or a block of code, you're essentially using the object's intrinsic lock. It's like each object comes with its own built-in lock that threads can acquire and release.
I see. So if I have a synchronized method in a class, it's using the object's intrinsic lock, right? But what happens if multiple threads try to access different synchronized methods of the same object?
In that case, only one thread can execute any synchronized method of that object at a time. The other threads will be blocked until the lock is released. This is because all synchronized methods of an object share the same intrinsic lock.
Interesting. Now let's move on to reentrant locks. How do they differ from object locks?
Reentrant locks, introduced in Java 5 with the java.util.concurrent package, which provides advanced concurrency utilities, offer more flexibility than intrinsic locks. They're implemented by the reentrant lock class. The key difference is that reentrant locks allow for more fine-grained control over locking and unlocking.
Can you give us an analogy to help understand the difference between object locks and reentrant locks?
Sure, think of object locks as single-key locks on a door. Once you lock it, no one else can enter until you unlock it. Reentrant locks, on the other hand, are like multi-key locks. You can lock it multiple times with the same key, and it will only fully unlock when you've turned the key the same number of times you locked it.
That's a helpful analogy. So, what are some advantages of using reentrant locks over object locks?
Great question. Reentrant locks offer several advantages. 1. They allow you to attempt to acquire a lock without blocking indefinitely. 2. They support lock polling and timed lock waits. 3. They can be made fair, ensuring that the longest waiting thread gets the lock first. 4. They provide methods to get the list of threads waiting on the lock. 5. They allow you to acquire and release locks in different scopes.
Wow, that's quite a list. Can you elaborate on the fairness aspect? How does that work?
Certainly. When you create a reentrant lock, you can specify whether you want it to be fair. If you create a fair lock, it guarantees that threads acquire the lock in the order they requested it. This prevents thread starvation, where some threads might wait indefinitely while others repeatedly acquire the lock.
That sounds useful. Are there any drawbacks to using fair locks?
Yes, there is a trade-off. While fair locks ensure no thread starves, they can have lower throughput compared to unfair locks. This is because maintaining perfect fairness requires more overhead in managing the queue of waiting threads.
I see. Now, you mentioned earlier that reentrant locks allow locking and unlocking in different scopes. Can you give an example of when this might be useful?
Absolutely. This feature is particularly useful in more complex scenarios, like implementing your own thread-safe data structures. For example, imagine you're implementing a linked list where you need to lock multiple nodes at once. With reentrant locks, you could acquire locks on multiple nodes in one method and release them in another, which isn't possible with synchronized blocks.
That makes sense. Now let's talk about a real-world implementation. How might these concepts be used in something like database transaction locking?
Great example, Sheila. In database systems, transaction locking is crucial for maintaining data consistency. Object locks might be used for simple, short-lived locks on individual rows. But for more complex operations, like those involving multiple tables or long-running transactions, reentrant locks could be more appropriate. They would allow for more fine-grained control, timeout capabilities, and the ability to check lock status without blocking.
That's really interesting. Now, what are some common pitfalls or misunderstandings developers might have when working with these locks?
One common mistake is forgetting to release a reentrant lock, which can lead to deadlocks. Unlike synchronized blocks which automatically release the lock, you must explicitly call unlock with reentrant locks. Another misconception is thinking that synchronized and reentrant lock are interchangeable in all scenarios. While they can often be used to solve similar problems, their behavior and capabilities differ in important ways.
Those are important points to remember. Do you have any tips or best practices for using these locks effectively?
Absolutely. Here are a few key tips. 1. Always release reentrant locks in a finally block to ensure they're released even if an exception occurs. 2. Use the try with resources statement with reentrant locks lock interruptibly method for cleaner, more reliable code. 3. Prefer synchronized for simple scenarios and reentrant lock for more complex locking requirements. 4. Be cautious with fair locks and only use them when necessary, as they can impact performance. 5. Remember that neither type of lock is recursive across different objects, meaning if method A synchronizes on object X and calls method B, which synchronizes on object Y, they won't block each other.
Those are excellent tips, Victor. Now, before we wrap up, let's reveal the answer to our quiz question. The main difference between object locks and reentrant locks in terms of flexibility is that reentrant locks offer more fine-grained control over locking and unlocking, including features like timed lock attempts, interruptible lock acquisition, fair queuing, and the ability to lock and unlock in different scopes.
That's right, Sheila. The added flexibility of reentrant locks makes them a powerful tool in a Java developer's concurrency toolkit.
Thank you, Victor, for this enlightening discussion. To summarize, we've covered object locks, which are built into every Java object and are used with the synchronized keyword, and reentrant locks, which offer more flexibility and control. We've discussed their differences, advantages, and use cases, as well as some best practices and common pitfalls.
It's been a pleasure, Sheila. I hope our listeners found this exploration of object locks and reentrant locks helpful in their journey to mastering Java concurrency.
In our next episode, we'll be discussing wait and notify mechanisms, another crucial aspect of Java synchronization. Don't miss it. And remember, if you've enjoyed this episode, please subscribe to Java Internals Crashcasts and leave us a rating. Your support helps us continue providing in-depth, accessible content on Java Internals. Until next time, happy coding.